Okay, we're going to be finding the distance between two parallel lines, and the shortest distance is a perpendicular line. So if you graph these, you find out that your y-intercepts are -1 and 9. You can also tell that from the equation, as I note here. From this, wherever the y-intercept is, you know your x is equal to 0. So we find the point of the first equation is 0, -1, and the second equation is 0, 9. Now we're just going to be using 0, -1 for this, but if you use 0, 9, that's fine as well, as long as you're consistent. So the first step is to find the slope of the perpendicular line, so we can write an equation for it. Remember, you take the negative inverse of the slope of the parallel lines, so we get the slope equals -1/2. And we have our y-intercept for this equation already because we're setting the perpendicular line to go through that other parallel line. So since we chose 0, -1 to be that point, we know -1 is part of that equation. And we already know our slope from step 1. So y equals -1/2 x minus 1. That's our perpendicular line equation. Now we're going to set our perpendicular line equation equal to the equation for the other line. And we do this because where they intersect, their x and y coordinates will be the same. So the other equation I haven't used is the 2x plus 9. Therefore, I set -1/2 x minus 1 equal to 2x plus 9. And I find that x equals -4. And after I've solved for that, all I have to do is put that -4 back into either the perpendicular line equation or into the parallel line equation that I haven't used before. And I find that y equals 1. Now I have my second point, which is -4, 1, and we use that point. And I'm going to use the 0, -1, oops, I circled the wrong one, 0, -1, and the -4, 1 to find the distance between those. So here's the distance formula, which you know, and I'm just going to plug in those points. So 0, -1, and -4, 1, and I will find that that my distance is the square root of 20. So again, you can go back and review this, booyah, by pausing.